Okay? Now, sometimes you'll have problems where you have to learn to reduce a fraction. And in particular, I'd like to do number 16 on page 92. Actually, I'd like to have number 17 on page 92. Then I'd have 17, 92, like Highway 1792. But unfortunately, there is no 17 on page 92. Next time I write a book, I'm going to try to have a number 17 on page 92. I almost made it on this one, but not quite. Number 16, it says the square, this is on page 92. The square root of 8 minus 4 square root of 3 divided by 12. Now, my question is, can you divide out the 4 with this 12? No, because the only time you can divide something out, a fraction, is if it's factored. So it's not factored. This is only a term. The 4 radical 3 is only a term, so you cannot divide out the 4. But what I'd like to do is simplify the radical 2, the radical 8. Can you simplify radical 8? We could make that probably 2 radical 2. Let me write that 2 radical 2, and then minus 4 radical 3 divided by 12. And now you can factor it, can't you? Factor out the 2, and what's left in the numerator? Radical 2 minus 2 radical 3 over what? 12. Okay? Over 12. Now, can you reduce this? Yes, because this 2 is a factor. So now you can reduce the 2 by dividing into the 12 and goes 6 times. So my final answer on this one is going to be the square root of 2 minus 2 square root of 3 divided by 6. Anybody tempted to divide out the 2 here?
No.
No. Okay, any question on that?
Would you get to negative 2 radical 3 in the bottom term?
Negative 2 radical 3? Well, I factored out a 2 from this expression. So I took out a 2, which leaves just the radical 2 in the first position. And I took out a 2, which leaves negative the other 2 radical 3. Okay, good question. All right? So that would be the final answer on that one. Okay, now I've got one more problem on page 93. And then I need to talk about rationalizing a monomial denominator. I guess we must be through with perfect cubes because I just erased them. Number 22 on page 93. It says 5 square root of 8 minus 6 square root of 50 divided by 10. Now what we'll have to do is simplify each radical first. Can you simplify the radical 8? 2 radical 2. Can you simplify the 50? Let's see, 50 would be what? 25 times 2. So that would be 5 radical 2. So what we have here is we've got a 5 times 2 radical 2 minus 6 times 5 radical 5. All
Radical 2.
Radical 2. I was just checking. Thank you. Ha! How many of you believe that? All right, divided by 10. Okay? Thank you. And then what? 10
10 radical 2.
radical 2 minus 30 radical 2 over 10.
Equals
These are like radicals, aren't they?
negative 20 radical 2.
Right? Combine like terms, that would be negative 20 radical 2 divided by 10. And then
Negative 2.
negative 2 radical 2. Negative 2 radical 2. Okay?
I was just wondering, you could have crossed out the 10 back here, right?
Not here.
Not here?
Not unless you factor it.
Oh,
Now, by the way, I tried to make a mistake up here a minute ago. And if I had made a mistake there, I'd have had a 5 here. Well, what if that was right? What if you came out with a radical 2 and a radical 5? Then you can't combine unlike terms, can you? So what would you have to do next? If this is a radical 2 and this is a radical 5. If this had been 10 radical 2 minus 30 radical 5, which is not, But what if it was? What if this is the new problem? Now what would you have to, you can't combine unlike radicals, can you? So you'd have to do some factoring, wouldn't you? So you'd factor out the 10, and what would be left? Radical 2 minus, and we took out a 10 here, which leaves radical 2. We took out a 10 here, which would leave
Minus 3.
3 radical 5 over 10. Okay? And then this 10 divides out with this 10. And the answer would be this. Okay? Now this is a separate problem. I don't want to have anybody confused and thinking that I somehow got from this problem over to this problem. This is a separate problem, but this is what you would have to do if it doesn't come out with the same radicals, which often it does not. Okay? Now I think that'll take care of reducing fractions with radicals. And now I'd like to look at denominators with radicals. Anytime you have radicals in the denominator, like 20 divided by the square root of 2, it's inconvenient to have a radical in a denominator. And what we want to do is eliminate the radicals from the denominator. This process is called